Hello, my name is Gertjan Burghouts. I'm a researcher at TNO at the Intelligent Imaging Department, where we focus on analyzing images and video. One of the projects that I'm participating in is called SNOW. It's about recognition of objects in an open world, where we didn't know all of the objects beforehand. One of the moonshot projects that was defined is called Bernard. It's about a search and rescue robot that can go into homes and find victims like people and animals and to rescue them. Relating to Bernard, there are three research questions that are important. The first one is to find the needle in the haystack. That is, finding victims in messy homes or houses and thereby also needing to interpret novel objects, because in a house you don't know what you will encounter, so the robot needs to be able to cope with that. Finally, the last research question is about how to adapt quickly to a new task or a new priority. In the home environment, we are looking at rescuing humans and pets. We need to search for victims, and that's really a needle in a haystack. Please take a look at these images and you will see that a lot of different objects are in houses, and some of them might be relevant and others are not. Here you see a lot of clutter, which is all not interesting for the task at hand, which is to find victims. We need to find objects and to adapt quickly to new tasks where new objects may be important. To experiment with this, we have been looking at toy humans and pets. That is, humans and pets are really abundant in all of these imaging data sets. So people and animals can be found in various data sets and various pre-trained models already. So we want to adapt to something new. So we used Bing to look for images, and we created a tool that automatically extracts images of relevance. Among them, pictures of adults and children, here being the toys, so like Barbies and other types of dolls, and also toy animals, like these stuffed animal pets, like dogs and cats. We want to quickly adapt to these new objects of interest and to find them in a house. The model needs to cope with novel objects that it didn't see before. Some of them might be relevant, some others might not be relevant. Please recall that our model has only seen these dolls and stuffed dogs and animals, and now it needs to find adults and children in this dataset, like the Barbie, which can be considered an adult in our dataset. It was not seen before exactly like this, but she should be rescued. That also holds for the other examples, like here, the relevant dog, which should be rescued, and also the child, which should also be rescued. But then the robot might encounter a unicorn, which of course looks a lot like these stuffed animals like cats and dogs, but it's different and it's not relevant for this task, so it should be ignored and not considered a cat or dog. This is in particular difficult because typically object localization methods and object detection methods always find some prediction. So if it finds a stuffed animal like this, it will probably say it's a cat or dog. And we need to ignore such predictions and to consider this as irrelevant for the current task. That's a hard problem. The reporting by Bernard is like this. So for instance, consider it finds this child. It needs to detect it first, then analyze whether it's relevant or not for the task. In this case, it is relevant because it's a child which should be rescued. Then it needs to be characterized, which you can see over here by a taxonomy. So here we used a knowledge graph for search and rescue, which recognizes both humans and pets. And for humans, it makes a distinction between children and adults. This taxonomy can be created on the fly, so it can be in a new way for a new task, and it needs to be defined by some expert that can input this to the system. Now Bernard outputs that, yes, rescue, this is a child, and it's really important that it also knows that a child is a human. because it then can prioritize humans over pets, for instance. Also, it may go down one level deeper of detail. So, for instance, children may deserve priority over adults and over pets. So then it's important to know that a child is a human and a child deserves priority. Putting all of these capabilities together in one model, we call a snow model. We first have a generic detector, which is a retina net. We embed the features using MobileNet, and then we analyze out of distribution analysis, which is really important to do the novelty analysis. That's a generative model because we don't have discriminative information there. We just want to understand whether this relates to objects that are relevant or not. Of course, for finding which object it is exactly, that is, when it's relevant, what is it, we use typical cross-entropy loss, but also a semantic projection, meaning that children and adults are more similar because they're both human to pets. And for this, we use a taxonomy and a semantic loss, which is implemented as a cosine loss. Object characterization is done in a discriminative way by optimizing this loss. And so we can say, yes, it's a relevant object and it looks like a child. The out of distribution analysis goes as follows. So suppose we encounter a unicorn as this example shows. It compares to all of the objects of interest, like for instance the stuffed animals that we encountered before, like cats and dogs. And we can also measure distances from those objects that it is close to other related objects. We can do that for all three of them. And then we can see that distances of the unicorn to the animals is larger than from the animals to other related animals. And this is a measure to say that this is out of distribution and hence should be ignored for the task at hand. So the model on the previous slide has been put together and put into action, which you can see into this demo movie. Here I pretended to be the robot rescue dog and climbed up the stairs with the camera mounted on my head. I'm looking for victims here, so I'm pretending to be the robot. On the left you can see the thermometer, indicating how relevant an object is for the task at hand, and on the right you can see the taxonomy. So it ignores all kinds of objects that it encountered, but now it finds a relevant object, being a dog, which is considered a pet, and that's correct. So this dog should be rescued. Then it moves on to other objects. It will continue, and here it will find a child. The child, of course, should also be rescued. And you can see on the red notes that it correctly was interpreted to be a child, which of course is a human and should be searched and rescued as such. Around the corner it will find a cat, but this cat is in such a strange position that it will not be recognized as such and ignored. Then the robot continues. Around the corner it enters a new room, ignoring all of the irrelevant objects, but here it will find a human. It's a child. And of course the child should be rescued. Please note how all of the clutter around the child and around the rooms, all the mess is all ignored. The robot continues to the next room where it enters, and it will find a lot of stuff, but it's all irrelevant. It also encounters the unicorn, which of course is not a pet and should be ignored as such, which the robot does. The robot continues, and around the corner it will find a rabbit. And the rabbit really looks like a pet. So the robot argues that it should be rescued. The robot moves on to the next stairs, and so it will go up one level, looking for more victims. Here you can see how the climbs are being taken, and the robot enters the final room, which is at the top floor. So the robot enters the last floor and the last room, which you can see over here. Again, a lot of small objects, all irrelevant, like the green flurry ball. And then around the corner, it will find another animal pet. But of course, this is not a house pet, so it is considered to be irrelevant, which is a good assessment. The robot continues to search and will encounter a Barbie, which is considered an adult. And that's the correct interpretation, given that we are looking for dolls as adults and dolls as childs. Now the robot will continue. It has found one adult and two children and two pets. And this is the final animal it encounters. But of course, this animal toy is not a pet. And it's considered irrelevant. And that's a good assessment again. Here is a blue monkey. It's a toy, but not a pet. And ignored as such. This is the summary of my presentation. I hope you enjoyed it. We've demonstrated that we can look for novel objects, that we can interpret them by a taxonomy or knowledge graph, and that we can also deal with a lot of clutter in messy environments. That was it. Thank you for your attention and looking forward to the next presentation.